Welcome back. So today we'll be looking at a chemical calculation topic where you will use moles in a lot of these calculations. You also need to know what relative formula mass is and how to calculate that. And we're going to look at all different types of calculations. Thanks to PixL for their slides that I pinched from them, but we'll be using and explaining things. So what I'm going to do in this PowerPoint is propose exam questions to you and then give you time to think about them, and then work my way through the answers together with you so you can see how to lay out your calculation for maximum marks in the GCSE exam. These calculations also do apply to the AS Chemist as well. So, first of all, you need to know what relative formula mass of a compound is, and once you know what the definition is here, then you need to look at how to calculate it by looking at the formulas. Question 3 is asking you the sum of the relative formula mass of the reactant and products. And question 4 is asking why can you have a relative atomic mass, which is not a whole number, for chlorine, which is 35.5, which is also on your periodic table. So lots of different terminologies here. We're looking at the word relative formula mass, we're looking at the word compound, formulas, the word reactant and products, and we're looking at relative atomic mass. So first of all, we need to know what all these words mean to you. So the word formula means is when you have two or more elements in a compound, like chemically bonded, like you got magnesium chloride over here, MgCl2 for example. Compound are chemically bonded elements which cannot be separated. And when we're doing a relative formula mass, we call it relative because we're taking an average of all the elements in that formula. So you then need to look at your periodic table to get those numbers of these to calculate, and you're looking at the relative mass number here. So for example, magnesium is 24, chlorine 35.5, and so on. Then the word reactant means when you're doing a chemical reaction, you start off with the reactants, and once you have reacted them, you make a product. And relative atomic mass is the number you get, like I said, on the periodic table, which is of your mass number, which is made out of proton and neutron numbers added together. So let's have a look at the answer to these calculations. So the definition in terms of exam board is relative formula mass is the number of atoms shown in the formula, like I said to you. And if I was to do the calculation for the relative formula mass, like I said to you, if I looked at magnesium on my periodic table, is 24, chlorine is 35.5, and then what you need to do, you will notice if there's no number means 1 here, and I've got 2 chlorines, so I just basically do 24 plus, because I've got 2 chlorines, there's 35.5 plus, if I add these two, it gives me 71. If I add the 2, it gives you 95. Now, in the next example, carbon, I'm going to do it down here for you. So I can put a little asterisk here, so do the calculation here. So carbon is 12, hydrogen is 1, and oxygen is 16. So these calculations down here. Now, these numbers are on your periodic table, and they are the mass numbers for these elements. So I've got 12 times 6 for carbon, because I've got 6 on the bottom, tells me 6 atoms there. For hydrogen is 1 times 12, because I've got 12 of these, and for oxygen I've got 6, so I'll do 16 times 6, and if I add them all up, it gives me 180. So that's how you calculate the relative formula mass. And why have I got a relative formula mass of 35.5? We'll talk about that in a minute because it's relative, and I'll show you how to calculate that. But what can we say about the sum of relative formula mass of reactant products? Now, if you're doing a balanced equation, you will notice the left-hand side is always equal to the right-hand side, and this is due to the law of conservation of mass, where energy cannot be created or destroyed. So let's look at the final question. And the question was, why can you have a relative formula mass 5.5? The reason being there's isotopes, so you're averaging out. So chlorine has an isotope of 35 and 37. So if you then average it out, it gives you 35.5. Right, so let's look at what other topics we're going to cover today. So we've looked at very briefly relative formula mass and balance equation, and I mentioned the conservation of mass to you. We're going to look at use of atoms and substances, which is moles, and some other calculations. So what we're going to do is look at a series of questions, and maybe you want to think about these or pause the video and attempt them. And once I've done the series of questions, I'll go through the answers. So 6, how many atoms in 1 mole of chlorine gas? Remember, 1 mole of atoms. It's quite important that you get the wording right. Next one, you got balanced equation where you got magnesium reacting with hydrochloric acid, giving you magnesium chloride and hydrogen. And it asks you how many numbers of moles of each substances there are. And next question, the term limited reactant. So I'm going to look at 2 further questions for you, and this one is where you got to work out how will you best balance the equation by doing the calculation. So slightly different ways of doing this, and you've been given 0.10 grams of hydrogen reacting with 3.55 grams of chlorine. That makes 3.65 grams of hydrogen chloride. So you got to use all those numbers and work backwards and balance the equation. Let's look at one final question before I start answering these for you. If 4.95 grams of ethene is combusted with 3.25 grams of oxygen, what is the limiting reactant? So you've been given the masses of ethene and oxygen, you've been given a balanced equation. What I suggest you do is you might want to pause each slide, have a go and do your working out, and then look at the answers. So I'm going to work you through each of these questions for you now. So just before we do that, I want to clarify a few terminologies which will make your life easier when you're answering those questions we've just gone through. The term mole is a measure of a chemical amount of substance. This is written by moles of MOL, but if you're in school, you will see when the teacher gives you chemical bottles, they have a capital M on them, which means the same. The word Avogadro constant tells you the number of atoms, moles, ions. Any of this terminology is acceptable. The value is 6.02 times 10 to the power 23 per mole, which is a really common exam question, is a positive 23. And how many atoms in 1 mole of carbon? The answer is 6.02 times 10 to the 23. Carbon 12 is what we compare our atoms to. Let's work through those answers now. So it asked you how many moles in 1 mole of chlorine gas. So because it's 1 mole, the answer will be 6.02 times to the power 23, which is the Avogadro constant. In this question, they have asked you what can the following equation tell us about the number of moles of each of these substances. All it's asking you to do is write down how many of these there are. So look at the numbers in front. No number means 1. There's 2 there, 1 there, and 1 there. So that's all you got to do is write down in words. A limiting reactant is a reactant in a reaction which is completely been used up, or when the other reactants are in excess. So that's what a limiting reactant is. Let's hope you've been doing well so far and marking your answers as we go on. How many moles of helium atoms in 0.04 grams? So this is the mass, and what you needed to do is work out the mass number for helium, which is 4, and all you've done is done 0.04 divided by 4 gives you 0.01 moles. What is the mass of 20 moles of calcium carbonate? And again, you look at the formula. So calcium's 40, carbon's 12, and you go 16 times 3 for oxygen gives you 100. The oxygen for 20, so you just do 100 times 20 gives you 2,000 grams. Be careful, the answer needs to be in kilograms, so you lose a mark in the exam. Kilo means 1,000, so divided by 1,000 gives you 2. Now, a little bit more to this question here. Calculate the mass of calcium oxide that can be produced when 300 tons of calcium carbonate has been heated. So we worked out the relative formula mass of calcium carbonate, which was 100 above. If I was to look here for calcium oxide here, 56, because it's 40 plus 16. So which then means it's 100 grams of calcium carbonate makes 56 grams of calcium oxide. So therefore, if I was to work out how much is in 300 tons, it will be 168. Question 12. Like I said, it was slightly complicated now. We are working backwards this time. So what we've been given, we got 0.10 grams of hydrogen, 3.55 grams of chlorine, and then we know the total of that. So hydrogen's 1, I've got 2 lots of it. Chlorine's 35.5 is Cl2, as it tells you in the equation, so I'm going to times by 2. And HCl is 1 hydrogen amongst the chlorine, gives you 36.5. So you've worked out the molar masses of all of them. Now work out the number of moles, which is mass divided by molar mass. The masses are above. All I've done is divided by the molar masses that you just calculated. That gives you the number of moles. And once you got the number of moles, you will realize that the ratios here is 1, 1, 2, 2. So then you just get 1, 1, and a 2. So the next question you had, if 4.95 grams of ethane again been given to you, combusted in 3.25 grams of oxygen, and what is the limiting reactant? So if I do C2H4, 2 lots of carbons, 24 plus 4 gives me 28, and then I've got 6 oxygens here. That gives me 2 oxygens here gives me 32 because it's O2, and the equation is 3, but I'm going to leave that for now. And then I've got masses. I've got for ethene 4.95 divided by 28 gives me 0.177 moles. And for oxygen, I've got 3.25 divided by 32 because it's 16 times 2. I've got 2 lots there. Now, if I look at the ratios in my equation, ratio here is 1 to 3. Hence, if I look at these numbers here, then I can just say if 1 mole of ethene makes 3 moles of oxygen, then I've got 0.177 moles of ethene. We'll need 0.53 grams of to react. So hence, this is the limiting factor. I don't have enough oxygen in this question. Okay, so hope this is good so far. And let's further look at some more questions for you. Okay, let's look at some different style of questions where this is a more of a triple thing because of the way the units are. So in this way, you've been given grams for sodium chloride and volume for dm cube. And the second one, you've been given concentration and the volume. And in the final one, a teacher has a concentration, you calculate the mass. So we're going to look at how these are done, just so you know, if you've not sure how to do them, just in terms of units. So just very quickly, 1 dm cube is equal to 1000 cm cube. Just if you need to do your conversions, I'm going to give you a minute so to work these out for yourselves and then go through the answers. Okay, let's have a look at the answer to them questions, shall we? Right, so in this, all we've done is we got the mass of sodium chloride is 50 grams in 2.5 dm cube. So we've just done 50 over 2.5, that gives you 20 grams per dm cube. If you divide the numbers, you divide the units too. In the second one, it asks you about the concentration. We know the mass and we need the volume, so we times it, and we just did it times about 1000 to do conversion from cm to dm cube. In the final one, we've got 25 cm cube, so we need to change it to dm cube, so both units are the same, so we can't have dm and cm. And then once you've done the unit conversion, you will just times it by 72.6. I hope you found this useful. Thanks to PixL for allowing me to use the slides to demonstrate all the different calculations we have in the GCSE curriculum. Some of these also apply to the A2 and AS chemist, like I said, for A-level students. Don't forget to subscribe and like. See you next time. Thank you.